Hello, I am Professor Sumit Chaturvedi from TIT Excellence. My department is CSEIML. Now I'm discussing Unit 4, that is a recurrent neural network. A recurrent neural network is a type of artificial neural network designed to process sequential data such as text, speech, or time series by using a memory to retain information from a previous step in a sequence. The main goal of the recurrent neural network is to process and understand sequential data like speech and text. Recurrent neural network aim to capture temporal dependencies allowing them to handle tasks such as language translation, speech recognition, forecasting, and sentiment analysis, where a sequence matters. Recurrent neural network is a powerful class of our neural network architecture, especially designed to process sequential data, unlike traditional feed-forward neural network, which assume which assume input to independent of each other. RNN incorporates a nation of memory that allows information to process across time steps. These time then particularly effective for tasks where context, order, and temporal relationship are essential, such as a natural natural language processing, speech recognition, time series prediction, and sequential decision making and reinforcement learning. Next, from the diagram of recurrent neural network, we have this is three layer: input layer, hidden layer, and output layer. And the hidden layer of data is processing. There are the many application of recurrent neural network: language generation, sentiment analysis, language modeling, conventional agents, image captioning, and text summarization and translation. One of the most application of RNN is natural language processing. Language is inherently sequential. RNN understands sentence by processing one word at a time while retaining context from earlier word. This capability supports tasks such as language modeling, sentiment analysis, text generation, machine translation, and named entity recognition and question answering. For example, in a machine translation, an encoder decoder structure based on the RNR convert a source language sentence into a context vector that generates a translate sentence step by step. Next one is long short term memory LSTM. Long short term memory is type of recurrent neural network that addresses the limitation of traditional RNN in handling sequential data by using a gather mechanism to selectively remember to or forget information. Its architecture includes a memory cell and types of gates: input, forget, and output gates. There are the three important gates of the LSTM: input, out, forget, and output, which control the flow of information, and allow it to learn long-term dependencies, data like text and time series. Long short-term memory is an advanced recurrent neural network architecture designed to overcome the limitation of traditional RNN, like vanishing and exploding gradient problem, particularly the vanishing introduced by the Sketch Harbor in 1997. LSTM are capable of learning long-run dependencies by incorporating a specialized memory cell and getting mechanism regulate information flow. And there are three gates used in LSTM. Number one is input gate. Input gate determines what new information should be added to the cell state. It uses a sigmoid gate and a 10H layer. It updates all the cell state which selected new content. Second gate is a forget gate. It decides what information from the previous cell state should be removed. It takes previous written state as current input. The output of value between 0 to 1 to scale all cell state content. Next one is output gate. It controls what part of the cell state should be exposed as a next hidden state. It combines current input and various hidden state to the compute output. It applies 10s to cell state and multiplies by get output. Training data objective testing is an important factor of the LSTM. This is known as input output pairs. Now we also use an LSTM objective to minimize the difference between the predicted and actual output. Testing after running test the model on unseen data on check. Gated recurrent unit. A gated recurrent unit is type of recurrent neural network that has two gates, update gate and reset gate, to manage the information flow and solve the variation gradient problem. It simplified the more computationally efficient version of LSTM network and used for tasks involving sequential data such as natural language processing and time series analysis. There are two gates in the gated recurrent neural network: update gate and reset gate. The update gate decides how much fast information to keep. The reset gate determines how much of the previous hidden state to ignore. When the reset gate is small, the unit focus on the new input. Second one is beam search algorithm. Beam search algorithm keeps the top k based partial sequence at each step, decoding to step instead of only one. It expands each candidate by possible next tokens and scores them. Only the k nearest scoring sequences are kept, balancing quality and computation. Attention model focus on the most relevant part of the input when generating each output. It assigns weight to different input positions based on their importance. The final output is weighted sum of the input features, improving context handling. Advantage of attention model: highly accurate, predictive and interpretable, easy to evaluate. Disadvantage: require data, more data. Many overfit issues also come into attention model, not ideal for tasks where ideals live are unavailable. Thank you from my side. I am Sumit Chaturvedi, professor, assistant professor in KIT Excellence, CSAM department. This is the fourth unit of machine learning, fifth sem AI for AI students.